Greetings everyone. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. Together we strive for a change through education. Ladies and gentlemen, today I want to take you through the first year university calculus, which is also relevant for TVET college candidates. Ladies and gentlemen, under the first year university calculus, will actually, for this video, ladies and gentlemen, I'll take you through what is called differentiation, particularly on the concept of product rule and quotient rule. If this is your first time watching my YouTube channel, kindly follow the channel ID at Kangaroo Maths and Science Academy. Don't forget to like, subscribe, and hit the bell notification for future video updates. Without wasting time, ladies and gentlemen, let's now start with the product rule and the product and quotient rules. Right, before I start with the product rule and quotient rule, I want to address something that is very, very, very important. This video actually is for those students or candidates who were in grade 12, who will be transiting to do their first year university, or will be doing their NCV programs or the NATED programs at TVET colleges. All right, without further ado, let's start, ladies and gentlemen. Number one, we need to be able to understand what is called the pre-knowledge. So in order to understand or to enjoy what is called the product and the quotient rule under differentiation, one must be able to understand what you have actually learned in grade 12, which is particularly called the rules of differentiation and first principle. Right, let's start. Number one, as a prerequisite, one must be able to understand, number one, the concept of first principles, which is actually defined as f prime x is equals to the limit when h approaches 0 of f of x plus h minus f of x all over h. So this is called the first principle formula. And this first principle, actually, we used the gradient of a secant to approximate what is called the gradient of a tangent. So it means we use f prime x, which is called the derivative of f with respect to x, which is actually used to determine the gradient at a point. So the objective of learning differentiation is actually to determine the gradient of a function at a point, which is actually called the gradient of a tangent. So this is what we have learned in grade 12. And secondly, one must be able to understand what is called the rules of differentiation. Rules of differentiation. In grade 12, there are 3 rules of differentiation that one must be able to understand. The first one, it says, if y equals to x to the power of n, Then now we can differentiate y with respect to x, which will be n x to the power of n minus 1. So this is according to the first definition. Let me try to repeat it here. It says if y is equals to x raised to the power of n, which is called a power function, then the derivative of y with respect to x, this will bring down the n. So it's going to be n x raised to the power of n minus 1. Number 2, it says if y equals to kx, whereby k is constant, then where k is constant, then the derivative of y with respect to x, the answer will become k. The answer will become k. Then the last one, it says if y equals to k, if y equals to k, where k is constant, then the derivative of y with respect to x, this is 0. So what does it mean? It means the derivative of a constant is 0. So these are the 3 rules of differentiation that we have learned in grade 12. And actually, you need to understand that according to the first one, it says when y equals to x to the power of n, then the derivative of y with respect to x should be like this. But when you have y equals to kx, where k is constant, the derivative of y with respect to x will be k. And the reason we're saying y, when y equals to kx, the derivative of y with respect to x is k, is because of, we can use this rule, rule number 1, to say, since this one, the n here, it's 1. So we can say dy over dx. So this will come down. So it's going to be k multiplied by 1, x into 1 minus 1. We're using this rule. And this would become k multiplied by x to the power of 0. And we know that in number raised to the power of 0, it's 1. So it will be k times 1, and the answer is k. So that's why the derivative here is k. So these are the 3 rules that we have learned from grade 12, which are very, 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 very important. And just to remind you, we can just look on one example. Imagine we have this, we have y equals to x cubic plus 4x squared plus 8x plus 9. And we can now determine dy over dx, which is actually called a gradient function. So now, when you determine this will become, if you're using this law, this will become 3x squared. Then this one will become 8x. And this is the kx. It will become 8. Then this one is 0. So it means this is the final answer. Right. Then now, how about if we are given this, ladies and gentlemen? How about if we are given this? We are given y equals to 8 over x to the power of 3. What would be the derivative of y with respect to x? What is the derivative of y with respect to x? If you are saying the answer is dy over dx, it's 8 divided by 3x squared. This is wrong. Because as you, if you recall very well, we cannot differentiate a function with respect to a variable that is at the denominator, according to what you have learned in grade 12. So which means we need to transpose the expression that is at the denominator to be at the numerator. So to do that, we're going to use the principles of exponents. So this would be, we first simplify y equals to 8, x raised to the power of minus 3. Then we do the derivative dy over dx. Then we use law number 1, rule number 1, which will be 8 into times minus 3, which is the end, then minus 3 minus 1. And this will give us negative 24 x to the power of minus 4. So if you want to leave the answer with positive exponents, that means this will be negative 24 over x to the power of 4. This is what you have learned actually in grade 12. But now, in grade 12, as I said, that we cannot differentiate this expression without having to write it to be in a standard form. And it means now, at university level, we'll be coming up with other methods that can enable us to differentiate this without having to simplify it first. So this is what we wanted to talk about now, ladies and gentlemen. So I was just addressing what you have learned in grade 12. Number 1, we know we dealt with first principles. And secondly is the rules of differentiation, like the one that I just mentioned now. So let's now take this further to what we call the product and quotient rule, ladies and gentlemen. Okay. This is just a pre-knowledge, which I strongly believe that you are aware of these things that I'm actually saying. This from grade 12. Remember, it's not about cram, pass, and forget. Right. Let's now move on to the second part. Before I talk about what is called the product rule and quotient rule, there's something that I want to address first. I want us to talk about what is called the derivative of a natural exponential function. The derivative of a natural exponential function. You have learned that in grade 12, when we have this expression, when we have y equals to a to the exponent of x, this is actually called an exponential function. Under functions and graphs. But however, when you talk about the derivative of a natural exponential function, we are referring to y equals to e raised to the power of x. This is called a natural exponential function. So the question is, how do we find the derivative of a natural exponential function? So in other words, how do we determine the dy over dx, which is a derivative? So according to the definition here, it says the derivative of any natural exponential function, it's always equals to e to the power of x, which means the derivative of e to the power of x, it's always equals to the e to the power of x. We need to prove this. But now, in order to prove that the derivative of a natural exponential function is just a natural exponential function, we need to first consider this definition in terms of limits. It says, if you are having the number e such that the limit when h approaches 0 of e to the power of 1 minus 1 over h. I apologize. The limit when h approaches 0, when e to the exponent of h minus 1 over h, this will become 1. So according to this definition, it says, if we have this function, e to the exponent of h, if we have the function e to the exponent of h minus 1 over h, then we apply limits. Then it says the limit when h approaches 0, then e to the exponent of h minus 1 over h becomes 1. Let me write this in words. It says, as the limit approach 0, approach or tends to 0, as the limit approaches or tends to 0, then e to the exponent of h minus 1 over h becomes 1. So this is according to this definition. It says, when the limit of e raised to the power, or when the limit as h approaches 0, then e to the exponent of h minus 1 over h becomes 1. So the question is, are we actually sure that it's true? So now I want to prove this using what you call the program to actually demonstrate this practically, just using different values of h to say, let's assume now the h, we say when h is around 0.5, we keep on reducing this h so that the h is smaller, such that it is closer and closer to 0. Let's say around 0.001. You see that 0.001, it is a number that is actually closer, or it's approaching 0. So if we say this is the number line, then here we have 0.5. So we see that if we keep on reducing the number, whereby the number is closer to 0. It's not actually 0, but it's, let's say, 0.00. You see that this number is actually closer to 0. So we wanted to know what will happen to the function when the limit is closer and closer to 0. When the limit tends to 0. This is what we want to talk about, ladies and gentlemen. So let's take this practically using what you call the Python programming. So let me share the Python notebook, the Jupyter notebook, to display what I'm actually talking about. So here it's my Jupyter notebook. Already I have imported the libraries that we'll use to display. For example, I've used NumPy for manipulations, pandas for data reading, the matplotlib and the seaborn. This is just to visualize. Then let's now run. If this is the first time watching my YouTube channel, kindly follow my YouTube ID at Kangaroo, Maths and Science Academy. You'll also find other videos that I've just created for Python. All right. Let's just wait for it to run. Okay. While waiting for it, let's now run the second one. Okay, let me just explain what is going to happen here. So what I've done here, I'll just say, okay, fine. With our function, e to the exponent of h minus 1 over h. So what I do, I'm generating multiple values of h. Let's say from 0.5, then up until 0.01. Then I want this value to be reduced from 0.5, but with the same value. It's getting reduced with the same value up until 0.01. So actually in Python, we'll use something called the linspace. Okay. Let's now run this just to visualize the function that I want to talk about here. Okay, you see, this is what I wanted to investigate. So now from here, I've just defined a function, call it the natural exponential, which takes in the number of iterations that I want to get. So this is the function that I want to display. So let me just copy this and try to compute it here. Okay, let's say if I put 20, what will happen? It will just generate values from 0.5 to up until 0.01, but 20 of them. So let's run this. You see that it has generated the values from 0.5. You see the values are getting reduced by the same amount up until 0.001. So what I wanted to do is I want to do this. I want to say, okay, for any value of h here, I wanted this to give me the output. So okay, fine. When h is 0.5, it means I'll have to put 0.5 here. It will be if the exponent of 0.5 minus 1 over 0.5, then it will give me the output here. Same applies. So now let's now do the running. Let's run the program without wasting time. Okay, now what I've done here is I just created an empty list to say from the definition, then I will say for any value of h that is inside this lane space, I want the function to take every value of h, substitute into the function, then which is the one that I just mentioned there, and append any value inside the list, then print the values. So now I'll just run this. Let's run this. Let's now give the values of the exponential function. Let me just to print these values, print v, just to observe here. You see that it says that when h is 0.5, when h is 0.5, the exponential value gives us 1.3. Just like that, up until 0.01. So this is what we got here. So now let's display these as a data frame. So when we display this as a data frame, you can easily see that here it shows the value of h. To say when h is 0.5, the output is 1.3, 0.47, 1.28, 0.45, 1.26, 0.42, 1. You see that when h decreases up until when it becomes 0.01, 0.01, then what is the output now? This becomes 1. But now let's now visualize this. Let's visualize this. Let me draw a line plot. Let's construct a line plot to actually visualize this output. And to do that, I'm going to say, okay, this is the code just to suppress any warning that will be here. Let's just run it. Okay, I'm going to say plt.figure. I want to give the size of this figure, fixed size, let's say 8 by 5. Then sn.line plot. So we want to construct a line plot with the x and the y value. Then what is the x value here? The x value, I think I'll just use the h. What is my h? My h is just this. So I'm going to say from a dictionary, I will say d of h as the key value. Then the y value should be the exponential function. So I'll just call it here. It's already there. So there it is from the dictionary. So that is my exponential. Right. Then I want to label this to give a title, plt.title. the line, the graph of a natural exponential, no, the graph of an exponential function. Okay, let me just say the line graph. So let's give a title, let's say PLT, no, let me say PLT.x label. Let's label the x-axis, let's call this the H. PLT.y label on the y-axis, let's just put this the exponential values. Exponential values. Then PLT.show, I want to show the plot, then so that we can do the analysis. Okay, let's run this. Okay, it says, okay, so it means, oh, okay, I forgot to close this. Okay. Right, you can easily see that this is the line plot, ladies and gentlemen. So I want us to do the conclusion here to say, want to observe like we want to know what will happen when the limit when h approaches 0 of e to the exponent of h minus 1 over h. By the way, the y-axis is the one which is e to the exponent of h minus 1 over h. Look what is going to happen here. Want to know what is the initial value of h here? H is 0.5. What will be the limit when h approaches 0? As h tends to 0, meaning moving from 0.5, the more h approaches 0, what is this function actual approaches? Remember, when it's 0.5, it was 1.3. 0.4, just some. We see that when h approaches 0, this function is getting closer and closer to 1. So we can easily see that when the limit when h approaches 0, e to the exponent of h minus 1 over h, this becomes 1 according to the limits. So we have proved that the limit when h tends to 0, e to the exponent of h minus 1 over h becomes 1. So it means wherever we see this, then we denote this to be equals to 1 according to the principles of limits. I believe you are following. So we've proved that the limit when h tends to 0, as h approaches 0, e to the exponent of h minus 1 over h equals to 1 or becomes 1 according to the definition. So we just proved that. Right. Let's now go back to our working. Right. Then now we can do this. We can say we've seen that when the limit of h approaches 0, of e to the exponent of h minus 1 over h equals to 1. Then now the question is, we want to prove that the derivative of e to the exponent of x is the same as e to the exponent of x. So we want to prove that when f of x equals to e to the exponent of x, therefore f prime x is e to the exponent of x. This is what we want to prove. Right. In order to prove this, ladies and gentlemen, we'll use first principles. And we know that when we are using first principle, we say, okay, fine. The definition says f prime x is the limit when h approaches 0 of f of x plus h minus f of x all over h. And to do this, it means we're going to say, okay, fine. We already have f of x. And if the f of x, it's e to the exponent of x, what would be f of x plus h? We have learned this in grade 12. This is the same as e to the exponent of x plus h. So which means from our definition here, we're going to say f prime x, it is the limit when h approaches 0 of, and we know this is e to the exponent of x plus h, minus f of x is e to the exponent of x all over h. And we know that from, according to the rules of, according to the laws of exponents, this expression here, it can be written in the form of e to the exponent of x times e to the exponent of h minus e to the exponent of x all over h. Now let's take e to the exponent of x as a common factor at the numerator. It means when you take it as a common factor, this will become the limit when h approaches 0 of e to the exponent of x. If we take this out, then we're going to remain with e to the exponent of h minus 1 all over h. And now, since the e to the exponent of x, since the e to the exponent of x is not a function of h, so we can pull it out. So this will become e to the exponent of x, the limit when h approaches 0 of e to the exponent of h minus 1 over h. And we have seen just from the last Python session that when the limit when h approaches 0, e to the exponent of h minus 1 over h becomes 1, which means this thing we're going to replace with 1. So it means this will become e to the exponent of x, e to the exponent of x multiplied by 1, which means the final answer is e to the exponent of x. So we have proved that if f of x equals to e to the exponent of x, then its derivative will still be e to the exponent of x. So we have proved that. I believe we are following. I strongly believe we are following. Right, now we can proceed with the product rule and the quotient rule, ladies and gentlemen. I believe we are following. Kindly don't forget to like, subscribe, and hit the bell notification. That would be much appreciated. Right, let's now move on to the issue of product rule and quotient rule, ladies and gentlemen. The product rule. Right, according to the product rule, it says, if we are given f and g, and these f and g are differentiable, so it means you can differentiate them. Then if we are given y equals to f of x multiplied by g of x. Remember, the word product has to do with multiplication. So in other words, product rule applies to where we're given two functions which are actually multiplied to each other. So we'll use product rule. Right, according to product rule, it says if y equals to f of x times g of x, whereby the f and the g are differentiable, you can differentiate them. Therefore, the derivative of y with respect to x, according to product rule, it says you take the first function, you differentiate it. Therefore, you leave the second one. Plus, The equation that you have differentiated, now you no longer differentiating it. And the second one is g prime x. Let me repeat this. So according to the product rule, it says, if you are having f and g, you differentiate f and you leave g. Now you leave f. Now you differentiate g. That is according to the product rule. That is according to the product rule. Okay? Then now, within this, we'll have to do an example to say, imagine you are given the following function. Y equals to 3x plus 4 together with x plus 2. And you are asked to determine dy over dx. Obvious. Method number one. If we use what you have learned in grade 12, ladies and gentlemen, step number one, you must first simplify. Let's just say from what you have learned in grade 12. So in the first method means we'll have to first simplify this expression. So in simplifying, then we're gonna remove the brackets. This will be 3x squared plus 6x plus 4x, then plus 8. Then we simplify this, y equals to 3x squared plus 10x plus 8. Then we can now start with the derivative to say dy over dx. This becomes 6x plus 10 because the derivative of a constant is 0. So this is the first method. Now, in method 2, I want us to use the product rule without having to simplify. Obviously, in terms of product rule, it means we must say, okay, we have y equals to 3x plus 4 together with x plus 2. So you see that we have two functions which are multiplied to each other. Let's call the first one the f, the second one the g. Just to repeat what I just said there, in terms of product rule, then you're going to say, okay, fine. What must we do here? We take the first function, we differentiate it. Then we leave the second one. Plus, the one that we start with, we're no longer differentiating it. Now we differentiate the second one. Let me repeat. Differentiate the first one, leave the second one. Then leave the first one, differentiate the second one. Now let's do the simplification. So this will be dy over dx. What is the first one? The first function is 3x plus 4. What is its derivative? Obviously, its derivative will be 3. The second one, x plus 2 plus first one, 3x plus 4. What's the derivative of the second one? The derivative of x plus 2 it's 1. So now let's simplify this. Remember, there's no need to show this. Let's simplify this. Remove the brackets. 3x plus 6. Remove the brackets by multiply by 1. 3x plus 4. 3x plus 4. So now this would be, if we were to simplify, the grouping like times 3x, this becomes 6x plus 10. You see that the answers are the same. The answers are the same. So now this is what I've introduced under the university level, which is called the product rule. This is what you're doing in grade 12, ladies and gentlemen. Now we introduce what you call the product rule, which is very, 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 very important. I believe you are following. I strongly believe you are following. Okay, we'll do another example. We'll do another examples later about the product rule. Very important. Okay. Okay. Right. Then now let's also introduce what is called the quotient rule. Quotient. This has to do with fraction. Quotient means it must be written in the form of a fraction. So according to quotient rule, it says, if you are given f and g, and these f and g are differentiable, so you can differentiate them. If you have y is equals to f over the g. So in other words, the quotient rule applies to when we are dividing expression, not when we are multiplying. According to this, the rule, it says when we have dy over dx, when you want to differentiate this according to quotient rule, it says you differentiate your numerator, which is the f. Remember, this is the numerator. Sorry, numerator. And this is the denominator. So according to the quotient rule, it says you take your numerator, differentiate it, then you multiply it with the denominator, which is the g, without having to differentiate. Then minus whatever we differentiated, now we're not going to differentiate it, which is the f. Now you differentiate the g. Then everything divided by the g of x in all squared. This is according to the quotient rule. The quotient rule says when we have dy over dx, let me say when you have y equals to f over g, if you want to determine the derivative of this, what you do, you differentiate your numerator. This is what you have done here. Then you leave out the denominator as it is. Then you subtract. Then whatever you have differentiated, now you leave the f. Now you differentiate the denominator. Everything divided by the denominator squared. This is according to the quotient rule, ladies and gentlemen. And this is very, 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 very important. Let's do one example. Let's do one example related to this. All right. With what, there's an example that I've already explained earlier. I wanted to use it now so that we can be able to prove. Imagine we have the following. We have y equals to 8 over x to the power of 3. We want to determine y prime, or what is called dy over dx. Obvious? Number one, we can use the first method of what you have learned in grade 12, simplifying the expression first, simplification. So it means you're going to say y equals to 8 over x to the power of 3. Then we transpose this to the denominator, to the numerator. This will be 8 x to the power of -3. So now we start doing the dy over dx. And this will be 8 into -3, x into -3, -1. And this will give us -24x to the power -4. Then we solve this in a standard form. This is -24 divided by x to the power of 4. Okay, this is what we have learned in grade 12. Now, in method 2, I want us to use say quotient rule, because we're dealing with a fraction. Quotient rule. So it means in terms of quotient rule, there's no need to simplify the expression. What is our expression? Our expression is y equals to a to the exponent of x cubic. What do you do? We have the f at the numerator. This is the f, and this is the g. So what is our f? Our f of x, it's 8. And our g of x, which is the denominator, it's x cubic. So which means we can even determine the f prime of x and the g prime of x just using the rules of differentiation. This is a constant. The derivative constant is 0. This one we're going to use rule number 1, which is 3x squared. Right, let's now write the definition. According to the definition, it says when you have dy over dx, what you do, you multiply the numerator. I'm saying you differentiate the numerator. You leave the denominator, which is the g, minus, then you leave the numerator, then you differentiate the denominator. Always you do this. Divide by the square of the g, which is the denominator. Like you differentiate numerator, you leave the denominator. You leave the numerator after subtracting, then you differentiate the denominator. And now let's do the substitution. What's the derivative of f over 0 times g? No, not is the derivative, it's x cubic. F is 8. What is the derivative of g? 3x squared divided by, what is g of x? G of x is x cubic, but it's in all squared. Let's simplify this. Already this is 0. It means you're going to have negative 8 times 3, 24 x squared over. This becomes x to the power of 6. Then let's use the exponents. So it's minus 24 x to the power. This subtract. Take one base, subtract. So it's 2 minus 6. So we're going to have minus 24x to the power minus 4. You see that is the same as this one. We can even leave it like this, or we write it to be in a standard form. So the answers are the same. So it means it's either you simplify or you use what you call the quotient rule. Very important, ladies and gentlemen. The quotient rule. Okay, right. Let's now move on. We have just went through the product rule and the quotient rule. I can summarize them now. Let me try to summarize them so that you are able to understand them. These are very important, ladies and gentlemen. Okay. In summary, We've seen that when the limit of h approaches 0 of e to the exponent of h minus 1 over h, this becomes 1. Number 2, we know that when you have y, when f of x is equals to e to the exponent of x, the derivative of e to the exponent of x is just e to the exponent of x. Number 3, in terms of a product rule, it says when we have y equals to f and g. It's not about f and g. We can use any other functions. So the derivative of y with respect to x, product rule, it says you differentiate the first one, you leave the second one, plus the one you've differentiated, now you leave it, then you differentiate the second one. This according to the product rule. Then the last one is the issue of the quotient rule. In terms of quotient rule, this has to do with fractions. When we use this when you're having fractions, it says when you have y equals to f over g, then the derivative of y with respect to x, according to what I said, we differentiate the numerator times we leave the denominator, minus we leave the numerator and we differentiate the denominator. Everything divided by denominator squared. This is very important, ladies and gentlemen. So now we'll use this in solving problems. Apologize. Right. Now, since now you are able to understand the product rule and the quotient rule, which is our focus for today's session. Now, we'll have to look on the examples. Let's just go through the tutorial to actually try to use what we have learned in solving problems. Apology, guys. Then now, in the tutorial, here is the tutorial. Right, here is the first question. The first question says, find the derivative of this function in two ways. By using the product rule and also by performing the multiplication first. And do your answers agree? So let's do that. We've seen that on the last example, when we are doing product rule, we have done the multiplication. Let's start with multiplication. Under the multiplication, what do we have? F of x is this. So it means we can expand this. We'll have to simplify first, multiply. This will give us x minus x squared. I believe we are following. Plus 2x cubic minus 2x to the power 4. So it's just this times this. Now you're following? Okay, 2x cubic. Then let's do the derivative. And this will just becomes 1 minus 2x plus 6x squared minus 8x cubic. This is what we got from the method number 1. Let's now go to method 2. Method 2, obviously, you're using the product rule. And we know in terms of product rule, ladies and gentlemen, when we say this is the F, I'll say, okay, I apologize. This is the H, and this is the G. So there's no need to do this, but I just wanted to show you something. So it means if we make f prime of x, so it means we need to differentiate the h, we leave the g, then we leave the h, now we differentiate the g. So let's do the simplification. What is the h? Obviously, the h is this one. So what is its derivative? Obviously, this will give us 4x. What is the g? X minus x squared. What is the h? 1 plus 2x squared. Derivative of g? Derivative of g is just 1 minus 2x. So if we simplify this, this would be 4x squared minus 4x cubic plus, we can expand this, is 1 minus 2x plus 2x squared minus 4x cubed. Let's simplify this by grouping the like terms. Okay, we have 1 here, it's 1. Negative 2x, the second one. Then look at this and this. These are like terms. This will become 6x squared. And even these are like terms. This will become minus 8x cubic. Let's now compare the answer. The answers are the same. So they're the same. So it means it's either you're using a product rule or just a multiplication. But there are some questions which do not require multiplication. They force you to use a product rule. We will talk about that. So you need to be able to know both of these. Okay? We actually use product rule when expressions are multiplied to each other. We'll use quotient rule when we're dividing expressions. Very important. I believe you're following. Okay? Let's now move on to the next question. The next question we're given, it says find the derivative of the function in 2 ways, by using a quotient rule or a simplification first. Why quotient? Because this is a fraction. Okay, let's start with the first one. Method 1. Let's just use simplification. Simplification. Obviously, what do we have there? F of x, it's x to the power of 4 minus 5x cubic plus the root of x all over x squared. So if I just using a simplification, it means we have to expand this. This will be x to the power of 4 divided by x squared minus 5x cubic divided by x squared plus, we know the square root of an expression is that expression to the power of half. So it means this will be x to the power of half over x squared. I believe you are following. Then now we're just gonna use law, exponent law. When the base is the same, we take one base and subtract. So obvious, when the base is the same here, we take one base and subtract. So it means this will be 4 minus 2, which is just x squared. Minus, then here, same base, subtract. So this will be 5, 3 minus 1, which is 3 minus 2, which is 1, plus same base and subtract. So it means it's half minus 2. So obvious, half minus 2, this will be negative 3.5. I'm saying negative 3 over 2. So it will be x to the power minus 3 over 2. So now we can do the derivative. Let's differentiate this. F prime x. This becomes 2x minus 5. Bring down minus 3 over 2 x to the power minus 3 over 2 minus 1. And this will give us 2x minus 5 minus 3 over 2 x to the power minus 5 over 2. We can either leave the answer in this way, or we can write to be in a standard form. Obviously, if you are writing to this will be 2x minus 5 minus, this will be 3 over 2 to the exponent of x to the exponent 5 over 2. So now, but just for simplicity, let's just leave it here. So let's write the answer that we got here. Let's just write the answer that we got. So when we use the first method, this is what we got. We got 2x minus 5 minus, let me just say minus 3 over 2x to the power minus 5 over 2. It's a 5. Now, I want to use the second method, quotient rule. We want to compare the answers. Obvious, in terms of quotient rule, ladies and gentlemen, we do not have, there's no need to simplify. There's no need to simplify. What we do here, because now it is a function of f, it speaks of f. So we can just say we let the whole of this, the numerator to be, let's say it's the h, this one to be the g. So now let's write this. What is the h? The h of x, it's the numerator, x to the power 4 minus 5x cubic plus x to the power of half. Now, what is its derivative? Let's differentiate it. This will give us 4x cubic minus 15x squared. I believe you know how to differentiate. Then half x to the power half minus 1, which is just minus half. Now, what is the g? The g is the denominator, it's x squared. What is its derivative? Is 2x. Let's write the definition. F of x prime. We differentiate the numerator. We leave the denominator, which is the g. Minus, we leave the numerator, and we differentiate the denominator. We divide by the denominator squared. Let's do the substitution. Okay, let me just substitute here. We're using method 2, the quotient rule. Okay, what is h prime? It's 4x cubic minus 15x squared plus half into x to the power minus half. What is the g? This one. G, we have its x squared. What is the h? The h, we have its x squared. No, it's not x squared, apologies. The h is this one. It's x to the power 4 minus 5x cubic plus x to the power of half. What is g prime? G prime is 2x. Everything divided by, what is g of x? G of x is the x squared, but it's going to be all squared. Now I want us to simplify this, ladies and gentlemen. I want us to simplify this expression. So what I will do, we'll just say, okay, fine, we have the f prime. Let's multiply in. So I'm going to multiply in by x squared here throughout in this expression. So we multiply in by the x squared inside there, and there also. So let's multiply by x squared. If we multiply by x squared, this will be 4 x to the power 5. Same base, minus 15 x to the power 4. Then now multiply this with this one. So there will be half. Remember, the base are the same. We take one base, so it's going to be negative half plus 2, which will be 3 over 2. Then now, here we multiply in by 2x. And at the same time, we remove the brackets by multiply by negative. So this means this will be negative, this will be negative. This one times that will be negative 2 x to the power 5. Then now negative and negative will be positive. 5x with this one, this will be 10 x to the power of 4, if I'm not mistaken. And lastly, this one and that, this will be negative 2 x to the power half plus 1, which is 3 over 2. Everything divide by, let's work out this. This will be x to the power 4. I believe you're following. I believe you're following, ladies and gentlemen. All right, let's now do the simplification. So I can get rid of this. Let's now simplify this. We're just using quotient rule. So let's do the simplification. Simplifying this, we're going to have f prime of x. Then we group the like terms. These two are like terms. So this will give us 2x to the power 5. These two also are like terms. Minus 15 plus 10 is minus 5. X to the power 4. These also are like terms. So half minus 2, this will give us negative 3 over 2, x to the power 3 over 2. Then everything to the power, divide by x to the power 4. So we can now simplify this. We can say this is 2x to the power 5 divided by x to the power 4. Same applies. X to the power 4 divided by x to the power 4. Same applies. 3 over 2, x to the power of 3 over 2 divided by x to the power 4. Let's now simplify this. We know exponents subtract. So this will become 2x. This one will become 0. I'm going to say 1. Yeah, even with this. Now about this they will also subtract. 3 over 2 minus 4. This will be minus 5 over 2. So we're going to have minus 3 over 2 x to the power minus 5 minus 5 over 2. Let's compare this answer. You see that these and these are actually the same. They're the same. It's just that this one is longer than the one we've done. Remember, there's some questions that will require you to actually use a quotient rule so that they're the same. We were just proving that. So it's very important to be able to know the product rule and the quotient rule, ladies and gentlemen. Okay, let's move on to the next question. Next question, what do we have? Okay, it says we need to find the f prime x. We need to find the f prime x and again the f prime prime of x. So it means we are doing the first derivative and the second derivative. I will just choose two of them. Okay, number one, let's start with the first one, number 27. So we are given f of x is equals to x to the power 4 together with e to the exponent of x. So they're being multiplied to each other. So which rule are we supposed to use here? Obviously, we'll require a product rule. And in terms of product rule, we can just call this the h and this the g. I'm not going to repeat this again, but let me just write it here to say we know f prime x. We differentiate the first one, we leave the second one. And we leave, secondly, plus we leave the first one, and we differentiate the second one. So let's now do this now. What is the first one? Let's do derivative. It's 4x cubic. And we leave the second one, plus leave the first one, and we differentiate the second. What is the derivative of e to the x? We went through that is e to the exponent of x. I believe we are following. You can even follow this route. Then now, what is the common factor there? Okay, I think there's something wrong that I've done here. I was not supposed to show it here. This should be a derivative, not a simplification. So it means I will have to do it like this and say f prime of x, differentiate the first one, 4x cubic, leave the second one, plus leave the first one, differentiate the second one. What's the derivative? It's e to the x. What is the common factor? There's something common here. So it's e to the x. So we're going to remain with 4x cubic plus x to the power 4, which is that. So now the second derivative also. Obviously, the second derivative, we're going to do the same because it's multiplication. You can call this h and this g, then we do the same. We differentiate the first one. The first one would be e to the x. Then we leave the second one. 4x cubic plus x to the power 4 plus, and we leave the first one. We differentiate this. If we differentiate this, this will be 12x squared plus 4x cubic. There's something common. It's e to the x. So we're going to remain with what? 4x cubic plus x to the power 4. This side, 12x squared plus 4x cubic. Let's simplify this. This will be e to the exponent of x. These are like terms. There will be 8x cubic. Okay, let's just write them in a standard form. So we're going to start with this. This is x to the power 4 plus 8x cubic plus the last one is 12x squared. This is the second derivative, but by using the product rule. Very important. You can also try this on your own. 28. Right, let's choose between 29 and 30. Any of this. Okay, we'll try 30 or even 29, but let's just do number 30. Number 30, what do we have? F of x equals to x over x squared minus 1. So number 30, what are we given? We are given f of x equals to x over x squared minus 1. So what we can do here, we can just say this is the H and this is the G. Quotient rule. I'm saying yes, quotient rule. What is the H here? Let's write the H. The H is X. So what is the G? The G is the X squared minus 1. So now what is the H prime? Obvious derivative of X is 1. And the derivative of G will just be 2X because this is 0. So now we're going to use quotient rule because it's a fraction. You see that we cannot simplify here. So quotient rule means we're going to say f prime x. We differentiate the numerator. We leave the denominator minus leave the numerator, differentiate the denominator, and everything to the power of divide by g of x squared. Now, what is the derivative of the numerator? We went through that, it's 1. It is g is just x squared minus 1. H is x. G prime is the 2x over, what is g of x? G of x is x squared minus 1 squared. So now we're going to have, let's remove the brackets. This is x squared minus 1. This is 2x squared all over x squared minus 1 all squared. Let's simplify this. This is just minus x squared minus 1 all over x squared minus 1 squared. So we cannot simplify this anymore. So it's either we take common factor of a negative. So this will be x squared plus 1 all over x squared minus 1 in all squared. So this is our f prime of x. So it means this time around, if you wanted to make f prime prime, we do the same. We do the same. We let this to be the h. We let this to be the h, and we let this to be the g. Then we do the same application. I believe you can do that. We still use quotient rule for the second time now. Okay? Right. Now let's move on. You can even try 29 and 28 on your own, particularly on the first derivative. You can try 28 and 29 and confirm your answer. So I believe this could be your activity. So what you can do, you can just pause the video, try to do this on your own. And after doing it on your own, then you check my solutions. Obvious, if you want to check the answer, confirm the answer, then it means there's no need for me to just go through all the workings. So I'll just do this. Differentiate the numerator, which is 2x. You leave the denominator as it is. Minus, leave the numerator, differentiate the denominator. Obviously, this will be 2. Then everything divided by 1 plus 2x squared, which is the denominator. Simplify. Multiply in by 2x. This will be 2x, 4x squared minus 2x squared over 1 plus 2x in all squared. Simplify this. Grouping the like terms, this will be 2x plus, these are also like terms. This will be 2x squared all over 1 plus 2x in all squared. So you can see that at the numerator, you can take common factor of 2x to remain with 1 plus x. Divide by 1 plus 2x. 1 plus 2x in all squared. I believe this is the answer that you're supposed to get, if I'm not mistaken. Remember, practice makes perfect. Okay? Right, let's now move on to the next question. You can also try to do number 28 on your own. Okay, let's now move on. The next question says, I believe this is the last one. The next question says, find the equation of a tangent to the given curve at a specific point. And we have learned from grade 12 that when you determine the equation of a tangent is just a straight line. So it means you need to find the equation of y equals to mx plus c. And we know a tangent touches the curve once. So it means to get the gradient, you need to make a derivative. So how are we going to get the equation of a tangent to this point? So it means now, number one, here we have our equation. So we have y equals to x squared minus 1 over x squared plus x plus 1. So we need to determine, must first find the gradient function, dy over dx. And to do that, by looking at this, by the way, guys, there's no need to simplify this. We're having a fraction. So it means we have to use a quotient rule to make a derivative. And you know how to do this. Remember, I said you can just say this is your f because then this is your g. And now I'm not gonna repeat that anymore, but it's fine. Let me just say it's f prime. You leave the g, you leave the f, differentiate the g, everything divided by the g squared. Okay? Equals to, what is the first derivative? 2x minus 1, which is just 2x. We differentiate the numerator. So we just have 2x. We leave the denominator, x squared plus x plus 1. We leave the numerator, x squared minus 1. Differentiate the denominator, 2x plus 1. Everything divided by x squared plus x plus 1. Let's do the simplification. We multiply in by 2x squared everything. So this will be 2x cubic, 2x squared, 2x. Remove brackets here. So this is 2x cubic plus x squared minus 2x minus 1. Everything, by the way, it's squared here, approaches. So it's x squared plus x plus 1 in all squared. Let's remove brackets. Is 2x cubic, 2x squared, 2x, 2x cubic, x squared plus 2x plus 1 all over x squared plus x plus 1 in all squared. Obviously, when you look at this, this will become 0. And now, what are we going to remain with? We're going to remain with dy over dx, numerator, These two are like terms. We're going to have x squared. This and this will be 4x. And the last one is 1 over x squared plus x plus 1 in all squared. By the way, what do you want? You want to calculate the gradient when given these points here. Remember, this is the x, this is the y. And to do that, we're gonna do this, ladies and gentlemen. Now we have a derivative function. And since we have a derivative function, then we can say we substitute by the value of x to actually get the gradient. And to do that, we're going to simplify from what we have learned in grade 12. We're going to simplify. When x equals to 1, remember this is the x value, we're going to say the gradient will be the dy over dx where x equals to 1. So it means from our equation where there is x, we substitute by 1. So this will be 1 squared 4 into 1 over. Then this becomes 1 squared 1 plus 1, but in all squared. So this will give us 6, 1 which is 3, which is 9. So it means the final answer will be 2 over 3. So it means the gradient is 2 over 3. And since the gradient is 2 over 3, we want the equation is y equals to mx plus c. What is the m? The m is 2 over 3x plus c. We have to get the c. And to get the c, we use that point because we know the value of x and y. The y value is 0. The x value is 1. So which means the value of c is negative 2 over 3. So the equation, the line of the tangent is y equals to 2 over 3x minus 2 over 3. So this is the equation of a tangent. That is the equation of a tangent, ladies and gentlemen. We are using quotient rule to do the derivative. I believe you're following. I strongly believe you're following, ladies and gentlemen. Then how about 32? Do the same. 32, we do the same. In 32, we want to find the equation of the tangent. Obvious. The tangent must touch the curve once. So it means to do that, we're going to sort of find what do we have here. We have y equals to e to the exponent of x over x. So it's a fraction. It means it will require a quotient rule. So let's do the derivative. What do you do? Differentiate the numerator. Obviously, it's e to the exponent of x. You leave the denominator, which is the x, minus, you leave the numerator, which is e to the x. You differentiate the denominator, which is just 1, over the denominator squared. I believe you're following. And now we can take, there's a common factor at the numerator here. Common factor, it's e to the x. So we're going to remain with x minus 1 over x squared. This is the gradient function. So now we know the x value and the y value. We're going to say, okay, fine. We want to get the gradient when the x equals to 1. It means in this derivative, where there is x, we put 1. This will be e to the exponent of 1 times 1 minus 1 over 1 squared. So obviously, you see that this is e to the exponent of 1. This is 0. And any number multiplied by 0 is just 0. So you know the gradient is 1. And if the gradient is 1, it means you're going to say y equals to mx plus c. What is the gradient? The gradient we know it's 0. So we can get the c only. The c we use that point. The y value is e. The x value is 1. So you see the c is e. Then now what is the equation? Remember the gradient is 0, so it's going to be y equals to e. So it's y equals to e, ladies and gentlemen. Remember, there are many ways to skin a cat. There are many ways to skin a cat. This is applicable to universities, first-year university students, and also those who are at the TVET colleges, maybe doing NATED or NCV. Need to be able to use product rule, quotient rule, and there are still other rules which we're going to talk about, which is called the chain rule. But now I just introduced these two. Then we'll also talk about how to make a derivative of trigonometric functions. Very important. Quotient rule, product rule are very important, ladies and gentlemen. And like what we have done here, for example, in 32, if we do not want to use quotient rule, we can even use product rule if you wanted to. Like number 32, because we have y equals to e to the x over x, I can take this to the numerator to say this is the same as e to the x times x to the power minus 1. So you see that we can use product rule because they're now multiplied. And if you're using product rule, the answers will be the same. Product rule says differentiate the first one. Leave the second one. Then leave the first one. Differentiate the second one. What would be the answer? This would be minus x into minus 1, which is minus 2. So let's simplify this. This is, if we take a common factor, we'll have e to the x. This will be x to the power minus 1 minus x to the power minus 2. We can either leave it like this, or we can simplify it like this. The answers will still be the same. 1 over x minus 1 over x squared. Then we work out this e to the x, and we multiply the denominator. This is actually x cubic. Cross multiply, this is x squared minus the x. So we're going to have e to the x, common factor at the numerator, it's x. So I can take x here, then I'll remain with x squared. I'm saying with x, not x squared. With x minus 1 divided by the x cubic. You see that this and this will divide, then we're going to remain with x squared. So you see that the final answer will still be dy over dx of e to the x into x minus 1 all over x squared. But even if we left it here and we substitute, we're still going to get the same answer. There are many ways to skin a cat. But we can use product rule here, but there's one property that I need to explain. It's called a chain rule, but we cannot use it now. I believe you are following, ladies and gentlemen. So the issue of product rule and the chain rule are very important in solving problems, particularly for those candidates who will be doing engineering, or those who will be focusing even more heavily on maths. It's very, very, very important, ladies and gentlemen. Very, very, very important. Right. This is the end of the session. Thank you very much for listening, ladies and gentlemen, and take care.